The ideal gas laws can be used to calculate the amount of gas needed to fill the airbag. Nitrogen's behavior can be approximated as an ideal gas at the temperature and pressure of the airbag. The ideal gas law is good for approximating the relationship between pressure and volume and the amount of nitrogen. The ideal gas law is P times V equals N times R times T, where P equals pressure, V equals volume, N is the number of moles, R is the gas constant, and T equals temperature. To be able to fill the airbag in milliseconds, a specific pressure is needed. After the pressure has been determined, the ideal gas law can be used to calculate how much nitrogen is needed to fill the airbag to this pressure. In the image over here, you can see that it gives like a kind of almost like a step-by-step as the airbag fills up to how much it needs to fill up in total. The ideal gas laws can also be used to estimate the pressure needed to fill an airbag. An estimate for how much pressure is needed to inflate the airbag in milliseconds can come from a mechanical analysis. It can be assumed that the initial velocity of the airbag is 0 and the final velocity is 200 meters per second, and it has traveled about 30 centimeters. The acceleration can be found by taking the final velocity and subtracting the initial velocity and setting that equal to 2 times the acceleration times the distance. We can then use the acceleration and a mass of about 2.5 kilograms to find the force by using sigma F equals ma. The reason the mass is so heavy is because the airbag moves so fast that it becomes heavy. Finally, by taking the force, we can get the pressure by dividing force by the area of the airbag. The amount of gas needed to fill the airbag can be computed by adding the pressure and the atmospheric pressure to get the absolute pressure. You can see in the little cartoon that it is a great force that comes out of the airbag that comes to hit the person, and the caption says, "Force distributed over small area."